Kumar, and here is a very important question from the very first test on Introduction of Calculus. Question is, use first principles to find the slope of the tangent line at the generic point P of A f of x equals to x square minus 2x. So we are given a parabola f of x equals to x square minus 2x, and you need to find equation, or rather expression, for the slope of tangent line at any general point. So we are taking point where the value of x is a, right? That is what it means. So using our definition of the limits, the slope of the tangent will be limit of, let's say, h approaches 0, of f of a plus h minus f of a divided by a plus h minus a, right? So which basically means that you need to substitute a plus h in the formula and then find the first term, and then substitute a in the formula to find the second term. Difference of these two is delta y, right? That is the delta y, and this is delta x, change in x, right? So we get limit h approaches 0, f of a plus h. Let's find the first term. So I'm writing it in brackets. It is a plus h whole square minus 2 times a plus h, correct? And then we have the second term, f of a. So that will be a square minus 2a, correct? Divided by h. So let us expand this. So we get limit h approaches 0. So we can write this as, okay, let's expand. So a square plus 2ah plus h square minus 2a minus 2h minus a square minus 2a, right? That is the numerator. And the denominator is h. Now let's simplify this particular expression. So a square and a square cancels out, right? A square minus a square is 0. So 2a minus 2a will also cancel out. So we are left with 2ah plus h square minus 2h. So I can take h common here. So I can write h, and then I have 2a plus h minus 2, okay, divided by h. Now we can cancel h and h. Once we do that, we can substitute h equals to 0 and find our answer. So we get, now we can substitute 0, so we get 2a minus 2 as a general expression for slope at any point on this parabola, right? So the answer here is that slope can be represented by, at any point, by 2a minus 2. So that is the rate of change, or the slope of the tangent line at any point on the graph. I hope that helps. And this is very useful. If I extend the question and I say find the slope at x equals to, let us say, 0, 1 and 2, then what you need to do is you just substitute these values here. So you know slope in general for any point a is 2a minus 2. Then at 0, how much will it be? So you say slope at x equals to 0, substitute 0 here for a, right? So if you substitute 0, you get minus 2. And slope at x equals to 1 will be, if you substitute 1 for a, you get 2 minus 2, which is 0. And if you substitute 2, so that means x equals to 2 or a equals to 2, we get 4 minus 2 as 2, right? So likewise, we can find slope at many different points by finding a generic expression and then substituting the values. And that is a huge application, where at times we prefer first to find a general expression and then slope at each and every point. I hope that helps. Thank you, and all the best.